Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear all participants. Good morning, hello. Yeah, okay. In this session, about the drug development, discovery, and we are very sorry because the second speakers still be at the Cengkareng, at the Soekarno-Hatta, Jakarta, because the plane is gone. Yeah. Okay. Yeah. Okay. In this morning we have topic about the drug discovery. Yeah, first is Professor Jumina. Professor Jumina is, you know about Professor Jumina? Professor Jumina is professor from Department of the Chemistry, Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, Yogyakarta. And he graduated as Bachelor in Chemistry from Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, and in 1997 graduated as a PhD in the field study of organic chemistry from the University of New South Wales, Sydney, Australia. Yeah, he talks about the all of chemistry. No. We invite Professor Jumina to speak about your topic. Your time is 40 minutes? More than 40 minutes? I think 40 minutes is enough. Yeah. Please come forward here.
Assalamualaikum warahmatullahi wabarakatuh. Okay, well, ladies and gentlemen, Bu Ani, thank you very much for your nice introduction. So in order to fulfill the invitation or the request of Professor Mustafa and Dr. Hamim Sadewa, this morning I would like to talk about part of my research activities conducted in our lab in organic chemistry laboratory. Actually, the research is done, and most of our research is done related to drug. It's done together with colleagues from Faculty of Medicine, either Professor Mustafa or Dr. Eti Darwaning Soleha. Yeah, so actually we have collaborated for a while. In Manipil, sunscreen, anti-malaria, anti-cancer, and so on and so on. But for this morning, I would like to talk about the development of potential sunscreen agent based on Calix for Resorcinarene. Bu Ani, can I? Yeah, because I have to operate my.
Okay, please.
Yeah, okay. Not working. Okay. Talking about sunscreen, we have to remember about the electromagnetic radiation, which in general cover a wide range of region in here, starting from high energy radiation in here, which is gamma rays, and then X-rays, until the long waves. Yeah. So the region are very wide. And when we talk about the sun radiation, sunlight, then what we consider is actually three parts of this region, which are visible spectrum in here, covering the region of 400 till 700 nanometers, and then UV radiation starting from 200 to till 400 nanometers, and then IR, infrared radiation, about here. So that is actually the sunlight radiation. And if we consider under the sunlight radiation in here, UV and then visible spectrum and also the IR radiation, then what we consider for this time actually is only here, is only this part, which is only about 80% of, So the composition of UV radiation in the sun is this one, only 80%, while the visible spectrum is 39%, and the IR radiation is about 53%. So actually what we are talking is only very little, or the very little part of radiation. Oh, come on. Please enter. Excuse me. Okay, and this is the type or categorization of UV radiation. Actually, there are three parts of UV radiation. We call it as UVA, UVB, and UVC, which differ in the term of wavelength or energy. UVE is having wavelength 320 till 400 nanometers. So it is the highest wavelength. The highest wavelength means the lowest energy in here. So it is the least energetic of the radiation in here. And it is not dangerous for us. So most of the UV radiation coming to the Earth is UVA in here. And the second is UVB, having the wavelength between 280 till 320. It is more energetic than UVA, and it is dangerous when comes to to our body. When it hits our body, then it can some problem. Till skin cancer is mostly caused by UVB in here. And then if you see, is the shortest wavelength in here, 200 till 280 nanometers. The shortest wavelength means the most energetic radiation in here. If you see, 200 till 280. But fortunately, even though it is the most energetic, the most damaging radiation of the UV, but most of the radiation is already absorbed in the atmosphere by the ozone layer. So it is not dangerous so far. As far as the ozone layer in our atmosphere is still okay. But when the ozone layer is becoming damaged, we call it as hole, for example, then UVC is becoming a serious problem for us living in the Earth. Excuse me. So why UVC is not dangerous, cannot come to the Earth when the ozone is still okay, and how is the role of the ozone in addition with the UV radiation? We can explain the phenomena by the Chapmans Cycle, which is describing the formation and the damage of ozone molecule. Ozone is O3 in here. So actually, the oxygen molecule present in the air, when it is hit by UV photon, having this is UVC, 242 nanometers. Then the oxygen molecule will break down homolytic to become two oxygen radical in here, or two oxygen atom in here. Okay, which is very reactive. And then the oxygen atom in here, the oxygen radical, will react with stable oxygen molecule in here to become ozone in here. O3 in here. And it is equilibrium, the formation in here, and some of the ozone molecule will release photon in here, UVC in here, 320, not dangerous one, to become this fragment again. So that is the equilibrium, the formation and the damage of ozone molecule in the nature, actually like that, the cycle. Okay, and part of the ozone molecule will react with some of the oxygen atom here to come back to this oxygen molecule in there. So that is the cycle. The formation and the removal of ozone is like that. So if there is significant influence in the atmosphere, then the cycle will be okay. The ozone layer will not be disturbed, but when the concentration of radical in our atmosphere is becoming higher and higher, then the equilibrium will becoming will be disturbed by the existence of radical, such as from freon, and other pollutant that can disturb the Chapman cycle. And that's becoming the extent of the whole. This figure shows us about the concentration of ozone in the atmosphere measured in the Antarctic area. So we can see in here, from 1980 to 2000, and here, the concentration in 1980 is about 205 Dobson unit. Dobson unit means one ozone molecule per billion of gaseous molecule of the air. So the figure is decreasing from time to time, from 205 to become about 100 in the year of 2000. So continuously decreasing. That is the concentration of the ozone really measured by the scientists in here. So when we look at the photograph of the ozone layer here, we can see in the year of 1983, the picture is still like this, but in the year of 10 years later, 1993, then the region here is becoming darker and darker. So here we can see the Dobson unit in here. The dark in here is around 100, like that, Dobson unit. While here is maybe still here, still about nearly 205. So that is the situation that we face nowadays about the ozone layer. Okay, so we can see the picture, the map of the concentration of ozone layer in our Earth. That here, the blue one in here, the south pole of the Earth is very low. The concentration of ozone here is only about 150 around here, 150 in here. That is the lowest region having ozone layer. What about Indonesia? Indonesia is here. Okay, Indonesia is here. This is the color is about blue or green. Blue or green. So it is, I think it's around here, 225 or 200, something like that. Well, what we, other region is okay, still yellow like that. So around 200, 225. Here is red, a bit higher. 300 and around 400. So what we should consider here, that there is part of our atmosphere having very low concentration of oxygen, and that we call it as the whole of oil. Here, the pole, the south pole of the